goal of this lecture is, at first I will see some basic question of system of linear equation which had come in CSIR net exam. This is basic question. At first I will see this question. Then I will see one question which depends on this theorem. Dimension, if W1 and W2 be two subspace of the vector space V, then dimension of W1 plus W2 equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. I will say one question based on this theorem. Actually, we all of us know this theorem is very important and very conceptual. So, I will see one example based on this theorem. So, we all of us know W1 union W2 does not have to be subspace, and it is a subspace if and only if W1 contain W2 or W2 contain W1. It is the set W1 plus W2. W1 plus W2 equal to the set containing X plus Y, where X belongs to W1 and Y belongs to W2. And this is obviously the subspace because 0 element always belongs to W1 plus W2. Second, W1 always contain W1 plus W2 and W2 contain W1 plus W2. So, W1 plus W2 always be subspace, and this subspace is the smallest subspace that contain both W1 plus W2. And if W1 equal to span of S1 and W2 equal to span of the set S2, then the set W1 plus W2 would be span of the set S1 union S2. Have you understood this concept? This is the properties of W1 plus W2. And the concept of direct sum is VBF vector space and W1 and W2 be subspace of the vector space V. Consider the set W1 plus W2 which is actually set containing X plus Y, where X belongs to W1 and Y belongs to W2. W1 intersection W2 may or may not be equal to 0 vector. It can be other element. If this is 0 vector, then U is the direct sum of W1 direct sum W2. This is the concept of direct sum. Today I will discuss some question about this concept. And now I will see one picture related W1 intersection W2 and W1 plus W2. This is the subspace W1, this is the subspace W2, and this is with the intersection W1 plus intersection W2, and this subspace W1 intersection W2 contain both W1 and W2, and this is the subspace W1 plus W2. This is the big subspace. This is actually big subspace from their union intersection. So, I have got 4 subspace on the vector space V. One W1, another W2, W1 intersection W2 and W1 plus W2. Okay. Now I will see why dimension of W1 plus W2 equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. Give just direction how we have to prove this proof. Then just see the any standard book, then you will understand in better way. The direction is, consider B be a basis of the subspace W1 intersection W2. Now extend the basis B to the basis of the subspace W1. Okay. Then B union S is the basis for W1. Now extend B to basis for the subspace W2, and this is considered, this is the T. Then B union T is a basis for the subspace W2. Now we have to prove, this is actually some difficult proof. We have to prove S union B union T is linearly independent. Then what is the basis for the sum W1 plus W2? We have to prove this. Then dimension of W1 would be, dimension B means number of linearly independent set who span the whole space. This would be dimension of B plus dimension of S, and dimension of W2 equal to dimension of B plus dimension of T, and dimension of W1 intersection W2 would be obviously dimension of B. Then dimension of W1 plus dimension of W2 equal to cardinality of B means dimension of B, sum dimension of S plus dimension of T by definition. And obviously notice dimension of W1 is dimension of B plus dimension of S, and dimension of W2 is dimension of B plus dimension of T. Here has extra B, and which is actually dimension of W1 intersection W2. So here the omit, here have used minus dimension of W1 intersection W2. So this theorem has established dimension of W1 plus W2 equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. Have you understood this theorem? Why this minus here used? Because for this, notice here dimension of W1 means dimension of B plus dimension of S, and dimension of W2 means dimension of B plus dimension of T, here extra B. So here have used minus dimension of W1 intersection W2 because this is the cardinality of dimension W1 intersection W2. I hope my all viewers have understood this theorem. This, if you know this direction, then if you see any standard book, then you will understand in better way. Have you understood? Okay. Now I will see some question which depends on this concept. So, at first I will highly recommend you, please see today's video with pay attention. If you see this video with pay attention, then your concept would be more clear. Okay, let's see the first question. Now I will see one question which had come CSIR NET 2018 exam. The question is the system of equation which defined as 1.x plus 2.x square plus 3.xy plus 0.y equal to 6. Here 2.x plus 1.x square plus 3.xy plus 1.y equal to 5. And here 1.x minus 1.x square plus 0.xy plus 1.y equal to 7. Option 1 has solution which is rational number. Option 2 has a solution which is real number. Option 3 has a solution which is actually complex number. Option 4 has no solution. Here these three equations represent one matrix 1, 2, 3, 0, 2, 1, 3, 1. Here 1 minus 1, 0, 1. And here the unknown variable is x square, xy, y. And here the b equal to 6, 5, 7. And the equation is such type ax equal to b. Is this solution has a solution? This non-homogeneous equation has a solution? For this, we all of us know, if rank of the matrix is equal to rank of the augmented matrix, then obviously there exists solution. At first, just reduce row equivalent form, then R2 dash equal to R2 minus 2 R1, then after row reducing, this row would be 0 minus 3 1, and then notice here would be this row, then R3 dash equal to R3 minus R1, then this is equal to 0 minus 3 1, okay? And notice these two rows are actually identical. So, third row would be 0 because these two row, second row and third row actual equal. Equal to 6 minus 7 1. That means rank of the matrix A equal to 2, but rank of the augmented matrix is equal to, notice here since non-zero, that means here equal to 3. So, since rank of the matrix A is not equal to rank of the augmented matrix, that means there exists no solution. Means option 4 is the right option. That means this system of equation have no solution. Have you understood this equation? Well, here in the option has indicate this equation has a solution in rational number. Here option 2 indicate this has a solution in real number, and option 3 indicate this has a solution in complex number. These three options actually wrong option. Have you understood? We will see one question which had come CSIR NET December 2018 exam. The question is, consider two subspace W1 and W2 of the space R3 and given by W1 equal to set of those element x, y, z belongs to R3 such that x plus y plus z equal to 0, and W2 equal to set of those element x, y, z belongs to R3 such that x minus y plus z equal to 0. And here two conditions described above this subspace. Condition 1, W intersection W2 equal to span of the set 0 1 1. Condition 2, W intersection W1 is orthogonal to W intersection W2 with respect to inner product of R3. Then option A has indicate W equal to span of the set 0 1 minus 1 0 1 1. Option 2, W equal to span of the set 1 0 minus 1 0 1 minus 1. Option 3, W equal to span of the set 1 0 minus 1 0 1 1. And option 4, W equal to span of the set 1 0 minus 1 1 0 1. This is very conceptual question. If you know the property, then you will understand in better way. Or in the question has given two condition. Condition 1, W intersection W2 equal to the spanning of this vector 0 1 1, and condition 2, given W intersection W1 is orthogonal to the set W intersection W2. For this, since here W intersection W2, that means W intersection W2 both contain the vector W and W2, and since W intersection W1 is perpendicular to W intersection W2, so for this consider one vector xyz from the set W intersection W2, and since W intersection W1 is perpendicular to W intersection W2, that means inner product between the set xyz with the vector 0 1 1 would be obviously 0. So since here the inner product of R3, that means here the inner product is only dot product, and dot product means 0 dot x plus y plus z equal to 0, that means y plus z equal to 0. Since in the question has indicate W is spanned by this vector, which of the option is true? In the question has given two condition. One condition, W intersection W2 is spanned by this vector, this one vector, and the other condition, the set W intersection W1 is perpendicular to W2, W intersection W2. And from this condition I have got y plus z equal to 0. And since both condition about their intersection, that means W intersection W2 means here, from here we can tell W intersection W2 contain on the subspace W. That means this vector also span the subspace W, and also given W intersection W1 is perpendicular to W intersection W2. That, and from this condition I have given one arbitrary vector in the set W intersection W2, and I have got the condition 1 y plus z equal to 0 by the orthogonality condition. That means from this condition the subspace W would be spanned by this set. A can be any arbitrary number, x can be any arbitrary number, and other y plus z equal to 0. That means if we consider y equal to 1, then z would be minus 1. Okay? And this vector always would be contain 0 1 1. Now let's see the option. Here W equal to, I have got spanned by this type of vector x comma 1 comma minus 1. Also since here 0 1 1. Now notice the option. First option has indicate W be the span by these two vector. Okay, if you put x equal to 0, then notice first option would be true, and notice second option spanned by two vector, these two vector. Notice second option, here 1 and here 0, so this cannot be true. And notice third option, W equal to span by these two vector. Notice here also 0, so this is also cannot possible. Okay, and option 4, W span by this vector here. Notice here also given 0, because here 1 always would be. So fourth condition also be wrong condition. Only option 1 is a right option. Have you understood this property? Have you understood this question? This question based on only intersection. Okay? Well, I hope my all viewers have understood this concept. This concept actually depends on intersection of two subspaces. And this intersection here given spanned by one vector, and here all condition depends what is the intersection of two subspaces. Then you will understand in better way. Okay? Well, now I will see one question which had come CSIR NET December 2018 exam. The question is, consider one subspace which is denoted as W1, and the subspace is such type the set content UVWX belongs to R4 such that U plus V plus W equal to 0, 2V plus X equal to 0, 2U plus 2W minus X equal to 0, and another subspace W2 equal to UVWX belongs to R4 such that U plus W plus X equal to 0, U plus W minus 2X equal to 0, V minus X equal to 0. Then which of the following is true? Option 1, dimension of W1 equal to 1. Option 2, dimension of W2 equal to 2. Option 3, dimension of W1 intersection W2 equal to 1. And option 4, dimension of W1 plus W2 equal to 3. This question is very basic question, but I hope my all viewers have understood how we have to solve this question, because I have discussed this question, this topic elaborately in my previous video. Also, I have discussed this topic few minutes ago, how we have to solve this topic. Here is the solution. Here this is the subspace W1, this is the subspace W2. For W1, this would be generate one matrix, this as UVWX, here X equal to 0, this vector contain U, this vector contain V, this vector contain W, and this vector contains X. And here 2V plus X equal to 0, that means here 0, 2, 0, 1. And here 2U plus 2W minus X equal to 0, that means this is 2, 0, 2 minus 1. And here the vector UVWX equal to 0 vector 0, 0, 0, 0. Okay? Have you understood this part? Okay. Sorry. Here would be 0, 0, 0. So here 0, 0, 0. Now the operation would be 2R1 minus R3. Then this value would be R3 dash equal to R2 R1 minus R3. Then this value would be 0. Here minus 2. Here 0. Here minus 1. Here UVWX equal to 0, 0, 0. Then here not minus 2, here would be plus 2, and here would be plus 1, because 2R1 minus R3. So this is the plus 2 and plus 1. And since here plus 2 and here plus 1. So now notice the second row. Then R3 dash equal to R2 minus R3. Then this would be 1, 1, 1, 0, 0, 2, 0, 1. And here would be 0, 0, 0. And here the vector U, V, W, X. And here the image 0, 0, 0. Have you understood? Okay. Now notice here only 2 pivot. The subspace W1, since rank is 2, that means dimension of W1 would be 2. That means option 1 is a wrong option. I have got dimension of W1 equal to 2. Now similarly we have to find the dimension of the subspace W2, similar method, just at first try to oneself, and W2, this subspace generate this matrix, okay, and if you apply R2 dash here, operation R2 dash equal to R2 minus R1, then you will get this row 0 0 minus 3, and notice here I have got this matrix, and from this matrix we can tell, since here I have got only minus 3 here, that means we can tell minus 3x equal to 0, that means x equal to 0, and from this line v plus x equal to, v minus x equal to 0, and since here I have got x equal to 0, that means that imply v equal to also 0, and from first law we can tell u plus w plus x equal to 0, and since I have got x equal to 0, that means u plus w equal to 0, that means u equal to minus w. That means the basis of W2 is such type, here u v w x, and I have got u equal to minus w, here minus w, and v equal to 0, here w, and here x equal to 0. That means this would be w times, if we common w, then this would be minus 1 0 1 0. So this is the basis of the subspace W2, and since this contain only one vector, that means dimension of W2 is 1. Okay. It's option 2 also wrong option. Dimension of W2 equal to 2. This is also wrong option. And here notice option 3. Here dimension of W1 intersection W2 equal to 1. For this we have to check the basis element of W1 also. Because if you can to find basis element of W1 and W2, then we can tell what is the basis element of W1 intersection W2. Because basis element of W1 intersection W2 would be the common element, common basis element of both W1 and W2. So here I have got the basis element of W2. Yes, we have to check the basis element of W1 also. For this subspace W1, since I have got u plus v plus w equal to 0, and from this line we can tell 2v plus x equal to 0. That means that imply from this equation w equal to minus u minus v and x equal to minus 2v. Have you understood this concept? That means the basis vector would be such type u v w x. This would be u v w x belongs to real number, and this would be such type, here u v minus u minus v and x means minus 2v. Okay, that means the basis vector would be u times 1 0 minus 1 0 plus v times 0 1 minus 1 minus 2. Okay, that means W1, the subspace W1 generated by the vector 1 0 minus 1 comma 0 comma 0 1 minus 1 minus 2 vector. Have you understood? That means dimension of W2 is actually nothing but, since this is generated by 2 vector, that means dimension of W2 would be 2, and dimension of W1 intersection W2. For this, notice here this vector for sorry, here W1. Here W1, dimension of W1 is 2. Sorry. Notice here for W1 is generated by this vector and W2 would be generated by this vector. Notice this vector is common in both W1 and W2. That means W1 intersection W2 generated by the vector -1 0 1 0. Okay, so dimension of W1 intersection W2 is nothing but only 1. Now notice the option. Indicate dimension of W1 intersection W2 equal to 1. This is right option. And here fourth option, indicate dimension of W1 plus W2 equal to 3. For this, dimension of W1 plus W2 equal to, we all of us know the theorem. This is dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. Here notice dimension of W1 equal to given 2, dimension of W2 equal to 1, and I have got also dimension of W1 intersection W2 equal to -1. That means this value equal to 2. So dimension of W1 plus W2 equal to nothing but only 2. Have you understood this theorem? I have told you this theorem is very important. If you know this theorem, then you can verify this option. But if you don't know this theorem, then you cannot tell what would be dimension of W1 plus W2. That means option 4 also wrong option. Have you understood? Okay. I will stop here. In my next video, I will discuss some question based on inner product space. But at first I will highly recommend you, if you don't see what is the inner product space, what is other property of inner product space, at first see the playlist, at first see this video, then our next video would be so easy. See you soon, stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.